to 770. Does anyone take the 2 classes before? Okay, that's good. That means you won't feel uncomfortable with course pace. And also, if some of you are already taking the CS 5000 level classes and you want to go back to solidify your foundations, or you want to review the basic knowledge, this class is a good place to go. Okay. And during the whole class, we'll from time to time to explore the basic concepts and algorithm by using Python. And also in the homework assignments, there could be some light programming tasks of using Python. So someone may feel worried about Python. So what if I never use Python? Is there anyone who never used Python before? Or never heard of them before? That's okay. So don't worry. The first point I want to emphasize that Python is extremely simple, yet very powerful, but it's extremely simple. And there are tons of tutorials or introductory in the web. And you are definitely able to write a Python program in 10 minutes. So in case that some of you might feel scared about programming, I give you 2 tutorials. The first one is a 10 minutes tutorial. It's very, very short, and just going through it, and you will know how to write your first hello world program. Let me scale it back. Forgive me for 30 seconds. Let me just open it from here. Anyway, let's just skip it. So this is just a blog. After class, you can open this blog, and just one article showing you the basic types, variable types of Python. How do you write down? And the Python only have one grammatical restriction. That is, you must use tab to align all of your code. That's it. Very easy. And also, this is also a very short introduction, but it's longer than this 10-minute tutorial. But it's more comprehensive. So I suggest every one of you who are not familiar with Python, just to spend like 10 to 15 minutes, look at those tutorials, and you're good to go. And the second thing, you don't need to worry about that. If there are some homework assignments regarding Python, it will be based on the demo we have explained in the class. And the code for those Python demo are shared with you. So if you have to do some homework with Python, you can directly edit your code according to the demo. So that's simple and easy. And finally, Python is really necessary for you to know something about data science. No matter when you are continuing onto the grad school, or you're looking for a job regarding data science, Python is necessary. It's very, very useful. So that's why I encourage every one of you have such kind of Python experience. So any question regarding the programming stuffs?
Mm-hmm. So what IDE we're gonna use in this class?
No restriction.
No serious. Okay.
No restriction. You can find any IDE you like to edit your code, and I often just use a simple notebook or Vim. But you can use other like Jupyter or whatever else.
I heard about PyCharm.
PyCharm. Oh, PyCharm is a famous IDE.
Oh, okay.
And there's some free version. You can use it as well. Yeah. Other questions?
What highest version of Python will be accepted in the assignments?
The Python right now has 2 branches. One is 2.7, I believe, the most classical way. And another is more advanced version is 3.1. And there is a little difference in grammars or library used in the 2 versions of Python, but both are acceptable. Yeah. And I guess in your assignments, you won't need to use those more advanced features in Python. So I think both versions will work. No difference. Any other questions? Okay, great. So let us talk about the book. So we'll focus on one book in our class. It's called Mathematical Foundation of Data Analysis. And this link is the web page of this book. And this link is a PDF. So you can download the whole book through this link. And don't worry, you do not need to buy it because it hasn't been published. It's actually an assembly of Jeff Phillips' course materials in these years. He spent a lot of time and correct typos and integrate them to an elegant and easy to read book. So you can directly download it. And in our book, in our class, we'll simply look at each chapter of this book and focus on it. And of course, in addition to this book, there are actual resources which I'm showing on the course web page. If you're interested, look into other materials, you can see the course web page. Right? But in the whole class, we'll focus on this book. Okay? And then prerequisites. So the official prerequisites only has 2 requirements that you need to take the CS2100. I believe it's discrete structures or discrete mathematics, right? So the requirement for this class as a prerequisite is that to ensure that you have a basic sense of mathematics. That's enough. And another prerequisite is CS2420. That's its introduction to algorithm data structure, right? As long as you have a tiny sense of algorithm design and how to deal with data, right? You have a sense of how programming is run, right? Then that's enough. So these are 2 prerequisites. And then let us talk about getting help, right? So as we from the class, as we mentioned earlier about the setting of office hours, we have provided plenty of office hours, right? Every weekday, each weekday, you have office hours. So don't be shy if you feel unclear about something we talked in the class, or you are unclear about homework answers or quiz answers. Just come to the office hour, and or send emails to the TAs and the instructor. Also, you can utilize the discussion forum in the cameras. Right? You're encouraged to initiate discussions. But please be careful. Do not post potential homework solutions. You are not allowed to publish a post saying that I think we should work out homework problem 1 as follows, blah, 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 give all the steps. This is not allowed. If we found such kind of a post, we'll directly delete it. The reason is that once you post an integral answer for that, you actually deprive some other students opportunity of thinking, right? Some students will just think, okay, I will just copy. But in offline, you're allowed to. Sorry, I don't know why it keeps doing like this. It's very important opportunity to master the knowledge and use that knowledge to solve problem. I don't want you to miss such kind of chance. So this is about getting help from the office hour and from the cameras. And here are the tentative course outline. And I don't want to talk them at this moment. At the end of this class, we'll briefly cover what kind of topics what kind of topics we're gonna cover throughout the whole semester. And let us skip it right now and go to the grading policy. I believe this is the one you guys are concerned most, right? What will finally show up in my transcript, right? A minus or B minus or B plus. That's an important thing, right? So, first thing, we do not curve your grade. So you are where you are. We do not curve your grade because we want to be transparent to every one of you. So your final grade will consist of two components. I mean the numerical grade. Right? Later I will talk about the letter grade mapping. Right? So the grading of your final your final grade consists of two components. One is homework and quizzes, which take 80%. That means 80 points. And the second is final exam. That takes 20 points, 20%. And there is no midterm exam. So you do not need to be nervous about the two exams. You just need to care about one final exam. And then let us discuss the two components one by one. So the first is homeworks and quizzes. So there are in total 5 homeworks and 4 quizzes. The homework will usually consist of analytic problems, like how do you prove two random variables are independent or condition independent, and how do you show their joint, how do you calculate the parameters or estimate the parameters of the joint distribution, right? This is typical such kind of problems. And occasionally there could be some light programming task, as I just mentioned, right? This is about homeworks. And for quizzes, so the quizzes are all of analytical problems and will be taken in class. Each quiz will be taken in about 30 minutes in class. And I don't want you to memorize every detail. So in your quiz, you can bring one cheat sheet, but you cannot bring a poster. Just one small cheat sheet. To be standard, it's a US like a US letter, right? But you can have only one side on that. That's for quiz. And you can write everything you think that could benefit your quiz. But besides that, there is nothing more to be allowed. Like you cannot bring, you cannot use your computer, you cannot use your cell phones, you cannot use calculators. And someone may be uncomfortable with calculators. If you do not use calculator, what if I ask you to calculate some very hard to compute values, right? Don't worry about that. You won't meet such kind of problems. So even there are some calculations, very light calculation, like how do you compute 1/2 multiplied with 1/3, such kind of things. So we are focusing on mathematical concepts and foundations. We are not treating you as a calculator. So among those 5 homeworks and 4 quizzes, and finally, we will drop the one with the lowest score. So finally, only 4 will be counted in our final grade. So then in total, that means each counted homework and quiz will take 10 points, right? Because we have 8 in total, right? So and it takes 80%, so each one will take 10 points. And you can take a look at your all homework grades and quiz grades from time to time. Then you have you will be very clear that which position you are in. Right? Oh my gosh. So this is about homework and quizzes. Any question about this?
Are there
a set date for the quizzes out, or?
Before any quizzes, we will publish the schedule in both the Canvas and also course web page, and tell you that when the next quiz will be. And also later, I will discuss with you the possible policies if you happen to miss some quiz. And then, so you can check out your grade, right? Each homework grade and each quiz grade in Canvas, and you have you'll be clear about your current position. You can make efforts, right, to go toward your expectation of this class. I think that will be very transparent to you, right? And then the final exam. So the final exam takes 20%, 20 points. And also, I don't want you to remember every details. Right? You can bring a cheat sheet as well. And this cheat sheet can have two sides. Again, it's a US letter size, and you can write down, you can fulfill the two sides, and you can write down everything you think is useful for your final exam. But again, there's no calculator, computers, or cell phones allowed in the final exam, and because we do not want you to ask question in Stack Overflow, right? I don't want you to ask a question, send a text message to your friends outside. Right? That should be it should be fair to all the students. Right? And this is about how we calculate the numerical value of your final grade. And then how can we map the numerical final grade to a letter grade? Right? That's very important. Because this is the one which finally shows up in your transcript, right? So here I give a very generous mapping. So you can say between as long as you are your final grade is no less than 82, you got at least A minus. Of course, if you want to get A, you must work harder. You must show that you are doing really good in this class. So if you want to get A, you must be no less than 91. But in general, this is not hard to achieve, right? Only past a little bit over 80, you can get A minus or A, right? And after that is B plus and B minus and etc. Right? And I won't use relative difference to determine your final grade. With that being said, you are where you are. You don't need to worry about how many other students perform better than you. As long as your final grade falls in those range, you get your corresponding letter grade. I'm happy that every one of you get A. So you don't need to worry about your fellow students. You only need to worry about yourself and work hard to get a higher grade. I believe this is your expectation, right? And then, as you may discover that this is kind of integer values, right? So what if your final grade values falls in the boundary between two different letter grades? So for example, if you get a grade which is 90.4, how can we round it to some integer value, right? So here is the policy. So we use the typical rounding strategies. Say if your grade is between 90.5 to 90.9, then we'll round it up to 91, means that you get A. Otherwise, if it is between 90.1 to 90.4, then it will truncate to be 90. Then you stay in A minus. That's a strategy. And some students might feel unsatisfied with their grade, especially in case of these situations. Right? For example, if I got 90.4, I only have a tiny more grade to lift my my letter grade in the final transcript, right? So what if I want to lift my grade? Don't give me the reason that, professor, I want to apply to grad school, so I need better transcript, or I want to get a good job, so the better looking transcript is very important to me. That's not reasonable. That's not fair to other students. So if you are not satisfied with your final grade, come to me. Bring your homework assignments, bring your quizzes, and bring your final exam papers, and we'll work together to find some places, to find some points for you. If I can find some extra points, then congratulations, I can lift your grade. But what if not? Then again, to be transparent and to be fair, you are where you are. That's the procedure. Does it make sense? Any question about the grading? Okay. And the important date. So because we only have one final exam, so the important date is for this final exam schedule. Actually, it has already been scheduled by the Office of Registrar. You can find out the schedule in the official website, but also I listed the final exam schedule here. So it is on December 12th, 2018, of course. It's between 3:30 and 5:30 p.m. in the exact same room here. 2 hours. Now let us talk about the late policy. So there could be the situations that some of you may submit the assignments late. Although I really don't want it to happen. But here I set up a detailed policy about this. So first, each assignment needs to be submitted or turned in through cameras. No problem about this, right? And the deadline is 15 minutes before the start of the class. So typically, that means it is 2:45. If your submission happen to be miss this 2.5 deadline, you will get 10% penalty. And if in the subsequent, if you continue to be late for the subsequent 24 hours, you'll get another 10% penalty. So for example, for a particular homework which worth 10 points, right? So if you submit your homework assignment like 30 hours later, then how many penalties you will receive? 2, right? Because first you pass 2.5 to 2:45 deadline, you get 10% penalties with 1 point, and then you miss another 24 hours deadline, you get another 10%. So you total lose 2 points. And that means that for that particular assignment, your grade is no bigger than 8. But all homework assignments cannot be turned in 48 hours later. If it is later than it is 48 hours or more later, then we won't grade the assignments, and your grade will be 0. So this is kind of a strict deadline. And also, the assignments will be posted early enough, very, very early enough. And it is, and the workload will be quite light. I believe if you spend like just a morning or afternoon and focusing on that, it is enough for you to solve. So with that being said, we won't accept the request to extend the submission of the homework. Of course, if you have some prolonged ill, like for example, I caught a bad cold and lasting for like 1 month, yeah, this is reasonable. But you need to show me the doctor's letter for the proof. And also after the grading of your each homework, if you feel that there is some error in the grading, it is possible. Although our TA will work very hard to ensure your grade is is correct. But if you think there could be some error, you can request for a regrading. And please send me a request within 1 week after your grade is finished. And then we'll ask the TAs to look at it again and give you the final grade. Give you the final version of the grade. And of course, this must be sent through email because we want to be transparent. So everything, each request will be documented. I apologize for this inconvenience. I don't know what happened to. So any questions so far? Okay, that's good. Then let us talk about homework submissions. So at the beginning, I briefly mentioned the LaTeX resource in my course webpage. So because most of our homework assignments will consist of analytical problems. That means you need to write down mathematical formulas, you need to derive mathematical steps. So I strongly recommend you to write your submission while LaTeX. So how many of you have heard of LaTeX? Okay, that's really good. So LaTeX is kind of a standard for writing technical stuffs or science stuffs. And so later in your grad school, or if your job is regarding to some research and development, if you want to write down some report, usually you have to use LaTeX. That's why I encourage you to have such kind of experience of LaTeX. It's very easy to use, and when you write down the formula, you will see the mathematical formulas and proof generated by LaTeX really beautiful, much better than using other word processing softwares like Word. Right? And also here, this link contains simple example files of the LaTeX files. You can simply follow that text files to write down your own LaTeX file and compile it. And also, because our homework assignment is written as LaTeX as well, so after we publish each homework assignment, we'll also release the text file for that. So you can directly edit that text file for your solution. So it'll be very convenient. But of course, someone of you might insist on handwriting, right? I like my writing. It's okay. If you really want to use handwriting to do your homework, please scan it clearly, and scan it to PDFs, and then submit to Canvas. But you should be careful that your write-up must be clear and legible. Otherwise, you may lose point, right? So any question regarding homework submission? Okay. And then let us talk about presence in quizzes and presence in final exams. So as we mentioned, we have 4 quizzes, right? And each quiz will be taken in class. So what if you happen to miss the quiz, you miss the class? The first strategy is that you can completely ignore that quiz, because our final grading will just drop the homework or the quiz which has the lowest score, right? So if you do not attend the quiz, that means your grade for that quiz is 0. Then we'll simply drop it. But don't do it twice, because if you do it twice, anyway, you will lose 10 points. This is the first strategy, very straightforward. And the second strategy is that if you have to miss the quiz or miss the class due to some emergency reason, and you really do not want to give up that quiz, you do not want to give up your grade, then send me an email and tell me why you are absent. Right? For example, if you have to see the doctor, you have to go to the emergency room, get the doctor's letter. Right? If it is reasonable, we can schedule a makeup quiz for you. And the TA will schedule such kind of, TA will make an appointment with you. And also, this makeup quiz will be taken within 1 week of the quiz you missed. And the problems in the quiz will be completely different from the one which you're supposed to take. So in that case, don't ask your fellow students about what they have been tested. It's not fair, and also it is useless. But if you just skip the class due to any other reason, sorry, we cannot make up a quiz for you. We cannot give you a makeup quiz unless it is reasonable. It is emergent. So similarly, attending the final exam. So we will keep reminding you when our class is approaching to the end. Meaning that we'll give you quite a few announcements to remind you to not to miss the final exam, because it takes 20 grades, right? But during the final exam, we won't count how many of you are present. If you do not show up, we have no idea. We only know it when we start the grade. So if you have to skip the final exam due to emergency reason, please let me know within 3 days of the final exam. Why it must be within 3 days? Because the winter break is quite short, only 3 weeks. We usually have to finish the grade. It's really annoying. We really have to finish the grade within 1 week past the final exam. So just let me know within 3 weeks and explain to me why you skip it. And if it is reasonable, we can schedule a makeup final exam as well. And also the makeup final exam will be held within 1 week of the final exam. And the problems are totally different. And some of you might have some schedule that you must skip the final exam. For example, you have some emergency reason, you must like leave. For some international students, you have to go back to your home country due to some emergency reason before the final exam. That's fine. And you need to notify me beforehand. And you can try to schedule a final exam ahead of the ahead. Right? Again, the problems will be completely different, and you will have less review time. Does it make sense? Any question regarding this? Okay, that sounds great. So then I want to discuss about the academic policy. So because this class is opened by School of Computing, so this class will strictly follow the School of Computing policy and guidelines, which is the link is here. So I encourage you to read it carefully, especially about the academic misconduct. So because we have a very strict policy about the cheating stuffs, and also according to the code of the Utah student, if the student is caught cheating on the homework or test, they will receive a failing grade for the course directly. So don't do that. And then under this academic policy, let us discuss what kind of collaboration are allowed. So for assignments, it is okay to discuss with your fellow students about how to solve it. We just mentioned before, right? And but after the discussion, you have to write down your solutions. You have to write your code independently. Namely, you have to write your own version of your homeworks. You cannot copy others and then give me the reason that, hey, professor, we have discussed together. This this is a solution we together come out. I just copy what he wrote. It's not necessary. It's not necessary for me to write it again. This is not acceptable. Even you after discussion, you two reach the same solution. Write it by yourself. And sometimes, if the two submissions appear too similar, meaning that you have exact same formula, exact same symbols, and line by line, even the commas are the same, then we might investigate whether this is cheating. So to avoid such kind of situation, if you two are collaborated such that you expect your homework submissions will look very similar, you need to add one paragraph of explanation about your collaboration, right, in front of your homework. Simply describing how you two are discussing with each other and how you finally obtain a solution. Then that will be fine. But if there lack of such kind of explanation and your submission appear to be identical or very, very similar to the other ones, then your grade could be set to 0, because it's kind of suspect of cheating. Does it make sense? And then for quizzes, final exam. For quizzes and final exam, unfortunately, discussion is strictly prohibited. So you cannot, during the quiz and during the final exam, you cannot discuss with anyone else. You have to finish the problems, finish everything by yourself. If anyone is caught during the quizzes or final exam, the particular quiz will have 0. You'll have 0 grade for this particular quiz. At final exam, you have 0 grade for the final exam. So don't do that. And okay. The last point I want to cover is the students with disabilities. If there are such kind of situations, do not hesitate and contact me immediately. We can set up a meeting and discuss how we can accommodate something for your study, and also notice the Center of Disability Service, and they will work together with me to make arrangements for accommodations. So far, any question regarding the whole course and the policies?
So I noticed that you have the web camera or the camera set up there. Are these like streamed to like YouTube, or are they? Yeah,
that's an excellent question. I'm gonna mention this point later. Yeah. Okay. So we will use video streaming to record the lecture video. I mean, in real time, and the lecture video will be uploaded into the YouTube channel called UFU Data. Let me show you the channel. So you can search in the YouTube UFU Data. And then this is the channel. This is the channel. And you can see here's this is a live now, right? Living now. It is uploading a video lecture in real time to the to this channel. So after class, if you feel you want to review it by looking at the video, you can directly go to this place. But that does not necessarily mean you can skip all the classes. Remember, we have quizzes, so don't miss the quizzes. This is important for your final grade. And any other questions? And also, I will ask TA to ensure the camera is facing on me, such that you won't miss what I have talked before. And sometimes I will use the whiteboard to to write down the formulas and then show you some proof, and then I'll ask TA to turn the camera to focus on the whiteboard. But it could be the case that the TA forget to turn the camera around. That could happen occasionally. I will watch that, but if it happens, please bear me with that. And actually, I plan to use the iPad pencil to show it such that the TA won't need to turn the camera dynamically to capture the whiteboard teaching, right? I want to project my derivations on board directly on this projector. Then everyone of you will feel even more comfortable. But let's see, because I found the device here today is problematic. I hope next time it won't happen. Okay, any other questions? Okay, another thing I want to mention is that I have to visit other university during this semester, so not during this week. So on Wednesday, I won't be able to give the lecture, and Professor Mike Kirby, our associate director, will kindly help me give the lecture talking about the probability knowledge. So because of his tight schedule, he's very busy. So that on Wednesday the lecture will only cover 50 minutes, but it should be pretty enough for all of the necessary topics to discuss. Okay. So now. In the remaining time, I want to discuss about the tentative course topics. So first, we will start from the probability knowledge. Is this font is too small? Okay, let me do the full. I don't know why this mouse is completely dead. Okay. Then we can go to the full screen. It's now look good. Even worse. Oh, maybe you can do the slideshow. Come on. Let me directly enlarge it. Does it look better? So anyway, we can just simply look at this. The important is the first few words. So don't worry about the extra words. I will introduce it. So first we'll take a review for the probability knowledge. So what is a sample space? What is random variables? Why would care so much about probability? Because in data science, in all branches of data science research, what's the main focus of that? What's the object for that? It is the data. We have to collect the data and analyze the data, right? Or extract useful patterns from data, or utilize the data to build up models for the future prediction. Then what's the properties of data? The basic property of data is that it contains a lot of noises. There are a lot of uncertainty in the data. That's why we will use probability, because probability is a rigorous mathematical framework to deal with uncertainty. So in this topic, we'll review those fundamental concepts like sample space. So what is sample space? Simply all possible outcomes for random variables. For example, if you toss a coin, right? So what are the possible outcomes? Yeah, heads and tails, right? So what are random variables? Basically anything you think there is some randomness, like the tossing result, the coin result, right? Or tomorrow's weather, whether it's raining, whether it's cloudy, whether it's sunny, right? So these are random variables, and we'll introduce the concept of independence. Right? So the independence is referred to at least two random variables, right? We can now say, okay, one particular random variable is independent to itself. That does not make sense. So we need to focus. We need to observe several random variables and consider whether they are dependent or independent. And then we'll look at the concept for probability density functions and cumulative density functions. So basically, cumulative density function is the probability that a random variable less than or equal to some particular value. So I believe these are already covered in your basic statistics class or probability class. Okay? And here we just want to pick up those very important concepts and review it again. And also marginal distribution and conditional distribution and joint distribution. Why we care about joint distribution? Because in our data science research or topics, we mainly have to look at many random variables together. Right? We're not looking at one single random variable. That's too easy. Right? We'll look at like thousands or tens of thousands of random variables together. That's why we need to care about their joint distribution. So this is about the probability review. And then we'll look at the Bayes rule. So how many of you have heard Bayes rule? Okay, good. So Bayes rule in a basic introductory course, especially in statistics, is a calculation rule, right? Calculation to compute the posterior distribution, right? Or compute a condition distribution, like given A, what's the condition distribution of B? Right? But here we'll explain Bayes rule from a different perspective. That is how it plays in the data science, in the machine learning. So actually, Bayes rule is very important. It takes a kind of a central role in probabilistic machine learning and artificial intelligence. It is a way to combine your prior knowledge, your prior experience, or even prior assumptions with the data you extracted, the knowledge you extracted from data. So after Bayes rule, you updated your knowledge by combining your prior experience and the newly seen data. And your updated knowledge is expressed as a posterior distribution. That's why Bayes rule is so important, because in artificial intelligence, we're trying to build up some intelligent agent, right, to learn experience and to expand their knowledge or capability when looking at more and more data, right, when doing more and more tasks. And how can we perform this kind of training or learning process in a rigorous mathematical way? Bayes rule provides the framework. So that's why we'll talk about Bayes rule and we'll talk about Bayesian reasoning. And then we'll go to the topic called convergence. So the first theory we want to discuss is about central limit theory. So central limit theory, how many of you have heard of it? Okay, it doesn't matter because we do not need to prove the central limit theory. I just want you to know this central limit theory. It is a core theory in the statistics. So basically it's saying, okay, if I have a type of random variable, no matter what kind of distribution of this random variable is, I even do not want to know what's the distribution of it. And suppose we have a bunch of random variables of the same type. And what about distribution of their average? The central limit theory tells us that no matter the original distribution of this particular variable is, the average of those random variables will asymptotically converge to Gaussian distribution. When the number of such kind of random variables is bigger and bigger, then the distribution of their average will become similar, closer and closer to the Gaussian distribution. This is a very kind of striking discovery and very insightful. It actually connects to many natural phenomena. And you will see in your senior class about machine learning and data science, if you have observed some continuous random variables, continuous observations, you will usually assume, okay, it is sampled from Gaussian distribution. And some people may ask why. Why I can directly assume it follows Gaussian distribution without thinking about it. Why? Because I can simply assume, okay, there are many, many latent random factors, right? And the observed value is just an average of those unknown latent factors. That's why it is. That's why the Gaussian distribution is repeatedly used as the assumption for modeling. And in addition to central limit theory, we'll introduce quite a few important probability inequalities. So what is probability inequalities? So basically, they are telling the behaviors of the random variables. So you can expect if you have a random variable, it could be it most likely appear around the expectation, the mean value, right? It won't go too far away. Then how can you quantify this? So what's the possible probability that it goes beyond the expectation, far away? Does such kind of probability will decrease very fast? How can we describe, or how can we quantify this kind of probability by using inequalities? This is what probability inequalities can offer you. Like for example, a famous inequality is called Markov inequalities, basically saying that a positive random variable, the probability when this positive random variable is bigger than some value is less than or equal to the expectation of this variable over this value. This is called Markov inequality, the one of the simplest probability inequality. So what does it reflect? So consider a random variable, right? So consider a very large positive value, like 1 billion. So what's the probability that this random variable is bigger than 1 billion? It is less than or equal to the expectation of this random variable over 1 billion. So then you can see that it will be very, very small. And other examples include like Chebyshev inequalities and Hopf inequalities, which characterize like how the change of random variables relate to the variance. Right? For example, what's the maximum probability of a random variable goes beyond the expectation within 1 standard deviation, within 2 standard deviation. And you can see there's a probability bound. What's the usage of this probability bound? It actually plays the key of critical role in developing learning theory. So why? Because in designing machine learning models, you actually incorporate the data, right? Remember, we mentioned that the data are considered as random variables. So the question, a very fundamental question, a very important question is that what kind of prediction performance when using all kinds of prediction data to test your learned model. Remember, your model includes the training data, which are random variables. That means your model is kind of random variable. It's very complex random variable. Okay? And then to evaluate the performance of your model, that means you want to evaluate some quantities of this random variable, which represent your model, right? So how can we quantify that? We'll use probability inequalities. So this framework, the framework for learning theory, which quantify the probability bound of the prediction error or generalization error, is called PAC learning framework. Called probably approximately correct framework. Why? Because it has to consider some uncertainty here. But you don't need to go into the detail right now. But later, for example, in the next semester, when you register the 5350 like machine learning class, you will know how the probability inequalities take effect to prove the PAC learning theory. So this is about convergence. And after that, we will jump to the linear algebra. So linear algebra, I guess everyone of you has taken the linear algebra course, right? So it is very, very important. So when I took the class in my undergrad study, I felt this course is quite straightforward and simple. But when I went to my grad study, when I took the machine learning class, I said, oh, I forgot everything. I need to read my book from scratch. So to avoid this kind of embarrassing things for you, and we will spend a few lectures to introduce the important concept in linear algebra. So you will find when you design a data mining model, or you design machine learning models, and you have to be very proficient about linear algebra, how to do the matrix calculation, how to do the inverse, and etc. So we'll cover the concept of vectors, the matrices, multiplications, and we will review the concept of orthogonality, right? What is linear independence? It's kind of strange to me that every time when I look at the linear algebra book, I feel, okay, this is really straightforward, it's easy, but after the book, after like 2 weeks, I forget everything. It's kind of, it's kind of weird to me. And also, we'll briefly introduce the important library in Python, numerical linear algebra library in Python called NumPy. So actually, you will find that later in your advanced class or in your job, which is supposed to be related to data science, you will heavily rely on the NumPy library. This is very beneficial for you to have some experience by using NumPy to calculate the matrices, matrix operations. And then we'll introduce the problem or task called regression. So what is regression? Simply giving you a set of variables. You want to use this set of variables to predict another variable. This is called regression. For example, given today's wetness and the temperature, how can you predict tomorrow's temperature? This is a typical regression problem. Giving you a set of variables, typically features, we also call it features, and how can we build a model to predict another interesting quantities? It's called regression. And actually, this is a very important research topic in data analysis. And right now, the research on this field is still going. So we'll start with very basic concepts and classical regression model. So we start with multiple regression. What's multiple regression? Very easy. That is, we have multiple variables, and we use multiple variables to predict one variable. It's called multiple regression. And what is a linear regression? Linear regression is very basic, right? But many classical algorithms are based on linear regression, and you should know that. And then we'll introduce polynomial regression. Perhaps it is the simplest nonlinear regression method. And later, maybe some of you have heard that deep learning or deep neural nets. Deep neural nets is essentially a nonlinear regression model. That's it. This is about regression task. And then we'll introduce gradient descent. So gradient descent is a basic framework for optimization. So in the future, we are trying to design some models. You must design some training algorithm, right, to fit the model to some observed data, training data. This is called training procedure. So what's the fitting procedure? Essentially, it is an optimization procedure. Your model is reflected in a so-called loss function. And your model training procedure is actually to optimize this loss function, typically minimize this loss function, to find some optimal model parameters. That means to implement your learning algorithm, you have to implement some optimization algorithm. So what is the basic optimization framework? Gradient descent. Very fundamental, very simple, but very, very important. So we'll cover the concept of a convex function. What is minimum? What is maximum? What is local minimum? What is local? What is global minimum? There's a difference between them. And what's the general step for carrying out the gradient descent? And then we'll introduce a very widely used but extremely simple gradient descent version called stochastic gradient descent. And stochastic gradient descent is the standard for deep neural nets. And interestingly, people find that if you do not use stochastic gradient descent to train deep neural net, then deep neural net just sucks. That's some interesting research problem that people are investigating why. And then dimension reduction. So dimension reduction is a very important technique for data visualization. Because in our real-world applications, we're studying different objects, right? Like human beings, like customers on Amazon, right? How can we describe customers? We usually use a long feature vector, like tens or hundreds of features extracted from their purchase history or profiles, such kind of things. But if you want to discover some patterns among these interesting objects, in our case it is customers, right? How can we find patterns according to those very high-dimensional feature representation? It is very hard. And then to address this problem, we have to depend on the dimension reduction techniques. How can we project this very high-dimensional feature vector into a two-dimensional space, namely on a plane? Right? So finally, say if we can use like just two-dimensional feature vector to represent each customer, and then we can visualize them on a plane, right? And then just from our eyes, we can say where are the communities, right? Where are the groups of customers who have the similar purchase interest, right? What are the outliers or anomalies? Right? So that's about the dimension reduction. We'll introduce the classical dimension reduction techniques called SVD, rank K approximation, PCA, and etc. And then we'll introduce the following two topics we'll cover, which is supposed to be at the end of the semester. One is clustering, the other is classification. So clustering basically is to find out clusters of data points in data, right? So this is also a very hot topic right now. People, the target of a problem formulation never changed, but the techniques has changed. So we'll introduce several very broadly used and very successful clustering techniques, like k-means, like mean shift. And many more advanced or even frontier research on clustering algorithm are just changes of this classical algorithm. And finally, classification. And of course, classification is kind of discrete regression. So if you want to use a set of variables to predict a binary variable or a discrete variable, this is called classification. Of course, it is another very important problem in data science, and we'll introduce like a linear prediction, like perception. And so the invention of perception is considered as the start of artificial intelligence. Also, it's very, very simple. So these are all pretty much we're going to discuss throughout the entire semester. And on Wednesday, we'll start with probability review. And again, And I apologize for the absence Wednesday, and Professor Mike Kirby will give a 50 minutes lecture on Wednesday. Okay, so I will see you in next week, and but we will get together again on Wednesday.
你有上这节课？